Excel, SQL, Python, Power BI, or Tableau 2 years ago, getting a certification, knowing all of these tools made you stand out. Today, it's table stakes. It's expected. Now it's baseline. Every applicant has it on their resume. Bootcamps teach them. And with AI models today, building with Python has never been easier, and troubleshooting and building out everything. These tools are no longer an edge. So here is what's happening right now that most people in this space aren't paying attention to. AI is supposed to be the next edge. Learn to use AI and you can get ahead, but that window is closing faster than most people realize because learning to use AI isn't enough anymore. The real edge in 2026 is learning how people are actually applying AI to compound their growth, specifically how to apply it in healthcare analytics in a way that produces real work, not generic output that looks like everyone else's. So the people who figure this out are going to pull ahead, and the ones who don't are just going to be wondering why they're getting passed over and getting left behind. In this video, I'm going to walk through the two camps that are fighting for your attention right now and why they're both wrong if you're trying to break into data analytics. I'm also going to show you the biggest names in AI. So I'm talking about the CEO of OpenAI, the co-founder of OpenAI, the CEO of Shopify, and what they're saying is the most important skill right now. And spoiler, it's not coding. Then I'm going to break down the layers of how people are actually working with AI in 2026 because most people are still stuck on layer one. And I'm going to share the exact workflow that I use inside my own job so that I can get the best output, despite the fact that I don't have access to the best AI tools to get the production level output that I want that I do have in my personal life. Quick background, I'm Jeff. I've been in healthcare analytics for over 13 years, and I currently work as a business analyst consultant at a top Fortune 500 healthcare company. And on my own time, I experiment with AI. I build AI tools, applications, AI agents, and automation projects that, frankly, I would have never believed I could have created months ago. And I've been compounding my growth with AI and learning on top of this and exponentially just keep getting better. AI is one of those things that you do need to jump on. And I'm on a mission to help 10,000 people break into data analytics, and I want you to be one of them. So hit that subscribe button so you don't miss any of this content. Now, right now, you're probably seeing that there's essentially two camps that are screaming at you and giving various advice. You'll hear camp one, which is going to be the more traditional path. Learn Python, learn SQL, learn a Power BI tool or BI tool, get a certification, grind leak code problems, and practice interviews till your eyes bleed. And this camp has been around forever. The advice isn't wrong, it's just not complete and needs to be updated because the market has changed under their feet, and a lot of it needs to be updated with how AI is advancing things. And then camp two is the hype machine. Just vibe code everything. AI will write the code for you. You don't need to learn anything technical, just learn how to prompt. And while that sounds great, until you realize that roughly 40% of junior developers are deploying AI generated code that they don't fully understand. And a study of about 500 open source projects found that AI written code had nearly twice as many major issues and close to 3 times the security vulnerabilities compared to human written code. And I'm not against writing code and vibe coding. I'm actually for it, but you need to still learn the foundations and the fundamentals to know when AI is giving you bad code. So you don't compound the bad code into more bad code. And then when you try to design it and try to redo everything, you figure out your architecture and your design is bad. And it's hard to just make a new change. It's learning the fundamentals so you know when things are bad. Because in healthcare, a wrong claims calculation, when it adjudicates and pays and makes a big mistake in the revenue cycle, means that real money and it's a real compliant risk potentially. So this is going to be the gap between it runs and it actually works that could cost someone their job because it makes a mistake in a critical area. Because I know this personally because I've lived it. early in my career, I had a fire drill. There was a meeting, it was a war room where everyone got on and we were running through the processes, and there was a mistake that affected a member negatively. And it was traced back to our department and ultimately my processes that I touched. I ran every sub process, I looked at every query, logic layer, I looked at the application, data pipeline, and then my manager walked over. Actually, the manager from our sister team walked over and looked like I was freaking out and talked to my manager to calm my nerves, because internally I was. Because this mistake literally cost the company millions of dollars. Luckily, it wasn't me. After we did more root cause analysis, it was upstream issue, but still, this was one of those moments where I literally thought I was going to lose my job, and it was a small data mistakes. Luckily, it was upstream and just my data validations didn't catch it, and it was like a unique error. But that was one of those things that it taught me that I need to have redundancies, and I need to be able to show that I put in the time and the effort to make sure that this error wouldn't have been caught. And one of the reasons why it wasn't caught was a human error that I missed because I wasn't taking my time with my validations. Now I take a lot more time with my validations. And this is also one of the reasons why I don't trust AI to do the validations on its own. I'll have AI teach me and help me build various validation tools that are deterministic, which means basically is a fancy word where the same inputs will lead to the same outputs, which is what you want, rather than AI doing it where it's non-deterministic because it's based on probabilities. That is one of those ways where you have to start learning to build with AI, and where the limitations, where the weaknesses are, so that you can apply it to your own workflow. And here is the thing: when I was the one writing every line of automation, every line of code, and building and architecting, I knew the logic because I built it myself. Now imagine AI generating those outputs at scale, and a person reviewing it doesn't understand most of what they're building. They don't even understand the design and how everything is fitting together. You can see how this is going to get out of hand pretty quickly, because you at least need to know how it's being built so that you can make the adjustments, and you can also know when things are going off the rails. And that's the real risk at an enterprise level that people who are vibe coding at a smaller scale aren't really talking about because they're not really exposed to it. And one of the biggest things right now is that AI has changed the economics of building software. Yes, you are an analyst, you're trying to break into data analytics, you might not be coding as much. However, I see where the industry is going, and because the cost of building software, what used to cost hundreds of $1,000s with a full engineering team can now be built at a fraction of that. And one of the reasons why I started learning about AI and why I started this channel is because I wanted the accountability to make sure that I started upskilling so I wouldn't get lapped by AI. Because there was code that I created that AI, ChatGPT, when I first used it, created in a fraction of the time. And I was scared. Now, working with AI, there's the opportunity. I know where I fit within the AI ecosystem, but that's because I've been working on it, I've been building, and I understand where the market is. And that's where I want you to be. And to hammer this point, there was a McKinsey study in February 2026 that surveyed over 4,500 developers. They found that AI tools cut routine coding tasks by 46% on average. And 90% of software companies are already using AI to cut development costs. This means that there's going to be, I already have seen non-technical coworkers being able to build tools for themselves instead of having to go to IT, having to go through a formal process. Now they can build automations that will speed up their work themselves. I'm living this as well. I built an AI agent framework and used OpenClaw, deployed it, and did a custom deployment of this with 7 security layers, a threat model, and I had zero prior security and network experience. This project would have been impossible for me 2 years ago. Now it's just like an everyday Tuesday where I take on new projects and I learn through the building in expertise and technical skills that would have taken me a long time if it wasn't for AI. And one of the reasons why this is also important for you trying to break into data analytics, this changes everything for career switchers because you can now build custom healthcare portfolio projects at a speed that wasn't possible before. You could build a claims denial dashboard for that specific company that you're applying to or specific niche of healthcare. You can build a HEDIS quality measure performance tracker, a risk adjustment audit tool based on the recent news that company published, or based on a blog post that one of the CTOs was talking about inside that company on their LinkedIn. It's coming to the point where now you have these opportunities to have an edge in the market because you have AI, but a lot of people aren't using it because they don't know that it exists. But here's the catch: the window is still early, but adoption is starting to pick up fast. The analysts who figure this out are still going to have an edge, but it's not going to be there forever. It probably won't be there a year from now. And if you get the earlier that you get in, the earlier you get to compound your growth and how fast you learn with AI. Because the ones who build with AI but build generic output are just going to blend in with everyone else, which is going to bring us to the real question: if AI can write code, what is the actual skill? So I'm going to break this up into four major layers to understand what the real skills are and where we should be putting our attention. Because you need to understand how working with AI has been evolving, because most people are stuck at step layer one. And let me catch you up. Layer one is prompt engineering. This is the foundation. And usually people start right before this, which is going to be zero shot prompting, which is basically you just give it a question and then get it back. It's just an over glorified Google is how most people are using it. But when you learn prompt engineering, this is going to be the foundation. At its core, it's structured communication. You're learning how to communicate better to get better output. So when you write these prompts, it's going to be you set the role, you define the task, you give context, you specify the format, you show examples, set constraints. And if you've ever said something similar, help me with this data generally, and then gotten garbage back and things that you couldn't use, and then you learn some prompt engineering techniques, and then you update it to something. You are healthcare analyst. I need a summary of denial rate trends by CPT codes for Q1, formatted as a table my director can scan in 2 minutes. Now you set a lot more context of what the model wants and your intent behind it. But here is what's interesting: the rules are changing because OpenAI just released guidance for their newest model to stop telling it AI how to think. Just tell it what you want and what success looks like. The older approach of writing pages of instructions and then saying you must and you must never in caps, those people who know, actually hurts the output quality now on these newer models. Role definitions are still important, but the fundamentals still hold, but the emphasis has shifted from handholding to cleanly defining the outcome, which brings us to layer two. Layer two is context engineering. This is where the industry is right now, or most of the industry is right now. Anthropic published engineering guide on it. The CEO of Shopify endorsed the term directly. It goes beyond the individual prompt. It's about giving AI enough background about your world, your domain, your data, your team's problems so that it can operate at your level. And it gives you personalized advice, and not just one good question, but an entire information environment and context, so that it has enough information to process and make an informed decision. So this is something that you can do today, even inside Copilot at work with no fancy integrations. Just build a context document. What I had AI do originally was I had AI interview me. Then you have it extract your professional profile, your role, your team's problems, the data that you work with, the metrics that matter, your stakeholders, your processes, and then anything else that's important. You can even tell AI the context of why you're asking and have it interview that way. and then paste that in at the start of any session. And then I'm going to share how I did that in a minute. But let's move on to layer 3, which is specification engineering. And OpenAI's own alignment research team is now saying that clear specifications, or they've been saying clear specifications, not code, are the fundamental building block. This just takes all of what we just learned, the context and prompt engineering, to now be able to write specifications that are so good agents can take it and have longer running tasks and can do longer running work. This is the fundamental building block for agentic long running tasks. Write down what you want, who it's for, what success looks like, and how the model will know it's right. That's what literally analysts do when they write business requirements and when you're trying to create applications and just solutions inside the business. But now we're translating it and doing it for the models, and then making sure that we capture all the technical detail, all the context at a greater detail so that the models can execute on what we need. And then layer 4 is harness engineering. This one's a little bit more advanced, but I want you to know about because this is where AI in general is heading. A harness is basically the structured environment that you build around an AI model, and so that it doesn't go off the rails. So just think about it as the guardrails on a highway that you build so that, and then the AI model is the car. The harness is the lane markers, the speed limits, the checkpoints. Without the harness, the AI just drives whatever it wants, and then you just hope that it gets there. With the harness, there's a plan, you have different features that you can use, different use cases, even within the same model. That harness, which is basically the application and just like the things that are around it that you can use, will be better for whatever your use case is, depending on how they built that harness. Anthropic, OpenAI, Google, and Microsoft are all building these systems right now. And healthcare is a prime candidate because compliance requirements and the cost of data errors demand that level of oversight. You don't need to build these systems, but the analyst who understands why they exist, why the AI needs human verification, domain-specific evaluation criteria, that analyst is the one who's going to get pulled into AI implementation projects at their company. Someone who has to define what correct looks like for a claims report, someone has to write the rules for AI to follow. That's going to be domain expertise, and that could potentially be you in the future. Now, here is the through line across all 4 of those layers. Every single one of them move further from coding and is closer to the thing that you already do as an analyst. Understanding the business problem and communicating it clearly. This is going to be your edge, and this is how you're going to stand out in interviews when you can explain how you're working with AI. Because ultimately, AI is just another tool. There was Cobalt before Python. There was a bunch of old tools that we just don't use anymore. When you approach it as this is the tool for now, at the end of the day, what the business needs is for you to solve problems. So regardless of the tools that you're using, as long as you can solve the business problems and show impact, that's what ultimately matters. But now AI just compounds that and significantly multiplies your output and your productivity. So that's why you also need to learn AI, because it helps you solve business problems at a scale that we've never seen before. So you might be thinking, how does this apply to me? Because I'm just trying to break into healthcare analytics. So here is what the hiring data. So you might be thinking, I'm just trying to break into healthcare analytics now. How does this apply to me? So here is what the hiring data confirms. Someone analyzed over 10,000 data analyst job postings from Indeed, LinkedIn, Glassdoor, and what they found was at the $50,000 to $70,000 level, companies care about SQL, Excel. At the 90,000 to 120,000 level, they barely mention Excel. They want someone who builds dashboards that drive decisions and solve problems. At the $130,000 and above, they're not hiring analysts, they're hiring people who think like product managers that speak fluent data. That means they want someone who doesn't just pull the numbers when asked. They want someone who understands the business goal behind the request, who can look at the data set and say, here's the question that we should actually be asking, or here are the questions, this is how we should be refining our problem, Or let me ask these questions to uncover what's really wrong. And should we really be doing this? And is this the right direction instead? They're the people who can walk into a meeting and translate what the data means into a decision that the team can act on. That's the difference between someone who runs reports and someone who can drive outcomes. And here's a stat that stuck with me. One recruiter at a mid-sized tech company said she had 200 applicants at a senior analyst role. 190 of them could write a decent window function, but 10, she said, that she actually interviewed could explain why the analysis actually mattered. 109 people had the technical skill, only 10 of them understood the problem, and that's the gap. So with AI, understand all of these layers, just know that they exist, and now that you can start improving and moving into the other layers. Understand how to prompt better, learn about prompt engineering, start making your prompts better, and then move in and start documenting all of the different contexts so you can give the model so that they can work better, and then talk about your intent of what you actually want and what you don't want. That's a way to simplify all three of the different layers. And then the AI harnesses, don't worry about for now. Just know that whatever you're using needs to just apply for your own use cases and where your work lives. And where the companies that you want to go, you need to learn those different software and applications of AI inside there. So I hope that helps, because the question isn't whether you should learn to code, it's whether you're learning to think in a way that AI output is actually useful, because the fundamentals still matter. It's just being able to improve in how you communicate so that you can solve business problems. And if you want help breaking into healthcare analytics and support inside a community, I'm building the Healthcare Analyst Lab right now. So if that interests you, link is in the description below. And watch this next video because YouTube thinks that you're going to enjoy it. Click on it now.